question. Okay, arithmetic series. The sum of the terms of a sequence. So if you add up 1 plus 2 plus 3 plus 4 plus 5, what would you get? 3, 6, 10, 15. If you add 2, 4, 8, and 16, 6 and 8 are 14, and 16 is 30. Okay? There's a formula that we're going to learn here in a minute that will allow you to calculate those sums quickly. I mean, it's not hard to do if there's only 5 or 4 terms, but when we get into finding the sum of the first 50 terms, that is going to be a bit of a job, right? To add them up individually. It says it could be finite. Finite has a period at the end. It stops. That means there is only 5 terms. It could be infinite. Infinite means it continues on. All right? You can find the sum of many finite series in certain types of infinite series by using formulas. You might think, well, how can I add up an infinite number of terms and get a sum? Wouldn't it just get bigger and bigger as well? But we'll talk about that tomorrow. Here are the formulas. Sn, the sum of, could be 10 terms, 20 terms, 50 terms, whatever, is equal to n divided by 2. So if this is a 20, that number is a 20, and that number would be a 20. N is the number of terms, or the indicated term. What do you suppose A is? What was A in both Monday and Tuesday's lessons? The first term, that's right. Could be written T1. Some textbooks would write that as T1. What is D? A common difference. When would you use this formula? Only when you're talking about an arithmetic series. When you're finding a sum. You would use the Tn equals A plus n minus 1 in brackets times D when you're talking about an arithmetic sequence. What's the difference between an arithmetic series and an arithmetic sequence? If I went 2, 5, 8, 11, 14, this is an arithmetic sequence. And it would follow, like the formula that I could use to answer questions about this would look like the following. This is what we did on Monday. You could find an indicated term, like if I said to you, what's the 10th term? T10 would equal 2A plus 10 minus 1, 9, times D, the common difference. What's the common difference? 3. Nice. So 9 times 3 is 27 plus 2, 29. The 10th term would be 29. You could find like a number of terms. If I put comma and then the last term there. We did questions like that on Monday. Now, the difference between a sequence and a series is the commas become what? Addition symbols, plus signs. So this is an arithmetic series. And that formula is n over 2 times 2a plus n minus 1 times d. 2 times the first term plus the number of terms minus 1 times the common difference. Now, like if I'm doing this in the brackets, I would do the inner brackets, then I'd multiply it by d, then I'd figure out what 2a is, add those together, and then multiply by n divided by 2. There's another one. There's a separate formula. If you know the last term and the first term, you can just use this one. It's much shorter. A plus Tm. So you can add the first term and the last term, and then multiply them by the number of terms divided by 2. Is that okay? Today we're going to work with these formulas. It says find the sum of the first 100 terms. This is like a situation where the formula would be much more advantageous than going 1, 4, 7, 10, 13, 16, 19, 22, 25, 28, yada, 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 until you have 100 numbers, and then adding them all together. Nobody in their right mind would want to do that. Okay? Do you have this on your sheet, this particular question? And do we agree that A, the first term, would be 1? And do you agree that it does have a common difference? 4 minus 1, 3. Check the others. 7 minus 4, 3. 10 minus 7, 3. The common difference is 3. How do I know n is 100? Yeah, it says it right there, 100 terms. So in order to solve this question, I will write S 100, and it's going to equal, what would I fill in here? 100 over 2. Which is what? What would that simplify to? 50. In these brackets here, I'm going to have 2 times 1 plus, open another bracket. What would go in that bracket? 100 minus 1. Close it, and then I'm going to put the d value, the common difference, right here. Is that okay? The sum of the first 100 terms is going to equal 50. And then this is going to be 2 plus 99 times 3. Anyone okay, or is everyone okay with me doing that? Like, I'm not going to show every little step. 100 minus 1 is 99. 99 times 3. What would that give me? It would give me 297 plus 2. What would you get there? 299. So 300 times 5 would be 15,000, right? This is going to be 50 less than 15,000, which would be 14,950. 299 times 50. Check that out. Much quicker getting the sum of the first 100 terms than actually adding all 100 terms together. If it just said find the sum of the first 5 terms, you could argue it's quicker to just go the first term plus the second term plus the third term plus the fourth term plus the fifth term. Bam, you're done. The more terms, the more beneficial the formula is. All right. Find the sum of the following series. There's a little hint there. We'll get rid of it. You don't have this, obviously, on your sheet, do you? Can you copy that down? Find the sum of the following series. And I'll just hide this stuff too. So you get a half, plus 1, plus 3 over 2, plus 2, plus 5 over 2, plus 3, plus 7 over 2, plus 4. That's how it would go. All the way up to 20. Stops at 20. Some people struggle with this question because, one, they're not really sure if it's got a common difference or if it's got an error value. Everyone should be able to look at that and tell me what the first term is. 1/2. Excellent. Here it is right here. That's T1, or that's the A value. Now it's telling me there is a common difference. How do you find the common difference? 1, term 2, subtract term 1. What's 1 minus a half? What do you get? 1/2. Try this one. What's 3 over 2 minus 1? That'd be 3 over 2 minus 2 over 2. Also what? This would be 4 over 2 minus 3 over 2. Every time the common difference is a constant 1/2. That tells me that this is arithmetic. The common difference is also 1/2. Tn, 20. Attaboy, John. Okay, the last term is 20. Now here's the problem. If I just try and go to the Sn formula, like some people think, oh, I have the first and last term, why can't I just use this formula right here? Why can't I do that right now? It's calculating the sum. That's what I want. That's what it says. Find the sum. I do not know n. Way to go, Reese. I do know a. I do know Tn. Now, some people can look at this, and they know that n is what? Does anyone know what n is? How many terms would there be? A half, 1. It's basically 0.51, 1.52, 2.53, 3.54. There'd be 40 terms. That's right. So logically, you're solving that. There's 40 terms. But how could you solve that for sure? Like if you can't just logically work it out. How did we solve for the number of terms in an arithmetic sequence on Monday? I use this formula. And I'm going to solve for n. This is step 1. Find n. Write this down, please. What should I fill in for Tn? 20 equals. What should I fill in for A? 1/2 plus. I don't know n. What should I fill in for D? 1/2. Now, the other day, I was like moving this over, dividing both sides by 1/2. Then I'd add 1 to both sides. That's fine. When I look at this, though, however, watch if I multiply through the brackets. What happens to this 1/2 and this 1/2? Yeah, they're gone. So I end up with 20 equal to 1 over 2 times n, or 1n over 2. And what would you do to solve for n? Multiply both sides by 2. That's right. If I multiply this side by 2, I get 1n. Whatever I do to the right, I do to the left. 2 times 20 would give me 40. Is that the answer we were expecting? Yes? N is 40. Wicked. If n is 40, step 2 would be to find S what? Sn or S 40. Step 2, find S 40. I'm going to take the Sn formula. Now in this case, I could use either. I could use this one, or I could use this one. Thoughts? Which one would you go with? The shorter one. Me too, John. I would go with this. I would say S40 is going to equal 40 divided by 2 What was my A value? And my Tn value was 20. Is that correct? Oops. So S40 is going to equal 20. What do I end up with in here? 1 over 2. 20 over 1 would be what? How many over 2? So I would get 1 over 2 plus 40 over 2. Wicked. 20 times 41 over 2. That'd be 820 divided by 2. It'd give me 410. Or you could do this. Look. What's 20 divided by 2? 10. S40 is going to equal 410. Yes. Yes, sir. That's right. Yes, 20 is the last term. And we learned that on Monday, that Tn represents the last term, an indicated term, or the general term. Yes? It doesn't go on because this is a finite series. Finite means it finishes. Okay? Infinite means it could keep going on. So if you see the period or you see comma and then a number at the end, so when I wrote this or when we looked at this term, okay, it's not going on past that. It could go on, but they're asking you to stop or to add all the way up to 20. With me? So we'll talk about an infinite series later on, and we'll talk about infinite series that actually do converge on a specific sum. Some of them diverge. So like the more terms you add, the bigger the sum gets. That's what most people have in their brain kind of go back to or think, which makes perfect sense. But there are specific types of series that the more terms you add, actually you will get closer to a specific value. You can just. If I had used this formula, I would get the same thing. 40 over 2, 2 times A plus 40 minus 1 times a half. Pump the 40s in here, and the A value was also a half. So here's what this is going to end up like. S40 equals 20. This would be 2 plus 39 over 2. Are you with me on that? 40 minus 1 would be 39. 39 times 1 would be 39. 1 times 2 would be 2. If I add these, 20, 2 over 1 is going to give me what? Four over 2 plus 39 over 2. I got something jammed up. Here's my problem. 2 times a half is not 2. What is it? It's 1. Okay? 1 over 1 would be 2 over 2. It's going to bring me back to this same thing right here. S40 is going to equal 20 times 41 over 2. What's 20 times 41 over 2? It's 820 over 2, which is 410. Or you could divide first before multiplying. Answer's 410 either way. Cool? So we are calculating sums. Don't forget that the arithmetic sequence formulas can help you find the number of terms and so on. All right, how many terms are in the series? 3 plus 8 plus 13. Well, let's hide all this information. Can you write this down for me? So Teniola, once again, this is a finite series. 3 plus 8 plus 13 plus all the way up to 248, and then they're stopping there. They want to know how many terms, what is n, and they give us this information. They give us the series itself, and they tell us what the sum is. They want to know how many terms. What are they actually asking me to find? What variable am I solving for? N. How many terms? Find n. Some people think I could just go to this formula right here. I know what A is. What's A? 3. What's D? What's the common difference? 8 minus 3, 13 minus 8. It's 5. That's right. What's Tn? 248. The last term. And what is Sn? What's the sum? 6,275. Now, can I go to this formula right here? How many terms are in the series? The last term is 248. What's the first term? Plus n minus 1 times 5. We okay with that? I could multiply this out. That's what we did in the last one. 248. 5n minus 5. Is that okay? Group your like terms. 5n minus 2. What would you do from here? Add 2 to both sides. 250 equals 5n. Divide both sides by 5. And what do you got? 50 equals n. There's one way to do it. If I had used this formula, this is 3. Sn was 6275, is that right? N over 2. A was a 3. What was Tn? 248. So 6275 equals n over 2. In there, I'm going to get 251. What would you do to solve this? To get n by itself. How would I get rid of this? Divide by 2. Multiply both sides by 2. That's going to give me 12,405.50 equals 251n. That 2 would cancel that 2. N times 251 is 251. N. 12,550 divided by 251. There's your 50. Couple of options in that situation. I didn't have to use this way or the other. Both give me the same answer of n equal to 50. There are 50 terms. Now, do you have to show both? Do you think I'm expecting that? No. You have to make a decision, though. Know that this formula works for an arithmetic sequence. It is helpful when we're working with arithmetic series. Okay, this one is only when you're particularly looking for a sum. I think there's one more example. Let's try this one down here, the one with the negative. Some negatives involved. What's it asking you to do? Find what? S20. So the first thing you should do with these questions is write down your given information. What do you notice right off the get? A value is negative 15. All right, the common difference. If you're not sure, what should you do? So I'm going to take term 2, negative 10, and I'm going to subtract John, term 1. 2 negatives make a positive. What do you get for a common difference? 5. Some people struggle with that. I'm adding 5. Negative 15 plus 5 would give me negative 10. Plus 5 would give me negative 5. Plus 5 would give me 0. And then it's going to go 5, 10, 15, 20, 25, 30, and so on. I want to add 20 terms. It wouldn't be that difficult for you to generate the first 20 terms and then just add them all up. I know that n equals 20. Why can I not use this formula? I don't know Tn. That's right. I could find Tn. All right, but then I got to find Tn, then find Sn. It's easiest for me to go with this formula.
Jimmy?
Yes.
Do you have Autumn Connick with you?
She's not here today.
Okay, thank you.
You're welcome. 2a plus n minus 1 times d. You're going to replace the n's with 20s. You're going to replace the a with a negative 15. And you're going to replace the d, common difference, with a 5. So that n is becoming a 20. This n is becoming a 20. A, negative 15. Another 20 going here. And then the common difference, 5. S20 is going to equal 10. And then in the bracket, I'm going to have negative 30 plus 19 times 5. That would be 50 and 45, 95. S20 is going to equal 10. What's negative 30 plus 95? 65. What's 10 times 65? 650. The first 20 terms are going to add up to 650. Is that okay? Any issue with that? We're almost there, folks. We're there. Number 1 to 8. So give that a try. It's exercise 10 point what? 10.7.